20th question. The 1 molar aqueous solution of following compound, which one will show the highest freezing point? Now, freezing point, if you see, delta TF is equal to KF into M. If it is 1 molar, what is different which will make the difference in freezing point? Because both seem to be constant. On that basis, it seems that molality is constant and Kf is constant. So how can we differentiate? You need to think in terms of the Van 't Hoff factor. It means it is Van 't Hoff factor which will make the difference. And Van 't Hoff factor is number of particles after dissociation. In this case, there will be dissociation. I'll tell you how. More about it, you will study in complex compounds. Okay? And number of particles before dissociation. Now consider one by one. And the rule is whatever is inside the square brackets cannot get ionized, does not get ionized. We will talk about it, coordination sphere in coordination compounds, okay, later on. So A, if I consider, it is CO and there are 6 molecules of water, Cl3. It will get ionized in COH2O whole 6 and 3Cl minus in these ions. So total number of ions after will be 1 plus 3, that is 4. Before 1. So in this case, I will be 4 divided by 1. That is 4. Okay. Yes, Vanna. That is something you can memorize afterwards. First, I need to explain it. Okay. So you will get I equals to 4 here. Similarly, these two chlorines will get ionized. This H2O will mix in H2O. So it is not an ion. Remember, although it is outside the coordination sphere, this is known as coordination sphere. Although H2O is outside, but it will mix with water. It is not an ion. These two chlorines will get ionized. So these two chlorines and this will become cation 3. In C case, this chlorine will get ionized and this cation 2 total particles after ionization. In this case, before and after same, 1, 1. It will not get ionized. There is no chlorine outside coordination sphere or no ionizable element outside coordination sphere. So if this is so, value of I is different, how it affects the freezing point? And the question is highest freezing point. So write it again. Delta TF is proportional to I. KF and M are constant. Molality is same thing. And delta TF is actually delta TF, sorry, TF naught minus TF. Initially, it is higher, then there is depression, so it will be lower. So in first case, delta TF, sorry, TF will be proportional to I, okay, and TF naught. So if you consider this one, just you can get from this one also, okay. This you have to find out. Question is, will show the highest freezing point. Highest freezing point, that one in which value of I will be lowest. Because suppose TF naught is 0. Suppose it is 0. If you need to say it is proportional to 4 or 0 is proportional to 3, 0 is proportional to 2, okay, or remove proportionality sign, have it equal sign, then it will be clear. So put the value of I here. When you will get 4, you will get 4, okay, proportional to when you have this one as minimum 0. Okay, I'm just explaining, keeping it positive so that you can understand. Say this one sum 50, then it will be easier to understand. Okay. From 50, how much you deduct to get 4? 46. From 50, how much you deduct to get 3? 47, 48, 49. In which case this TF is highest? When value of I is 1. Okay. I got few answers that I could do only question number 19, question number 20 I couldn't do. So for those, this is the way to find the answer for such questions. You will use this concept. I will be, or you say TF will be maximum when I is minimum, or other way around. To get I minimum, TF should be maximum. So you need to remember this. Instead of writing this much in such questions and get the answer, you need to remember just one statement. And that statement is Van Hoff factor is inversely proportional to TF, means freezing point. This is something you have to remember. If you decrease Van Hoff factor, the freezing point will increase, and vice versa. So if you remember this statement, in all such questions, you will require less than 1 minute. If you don't remember this statement, in all such questions, you may require 3 minutes. Yes, so D is the answer. Okay, so if you know the statement that Van Hoff factor is inversely proportional to freezing point, you will get the answer very quickly. Yes, correct, D. So write this statement somewhere. Van Hoff factor is inversely proportional to freezing point, or freezing point is inversely proportional to Van Hoff factor. Next question. Two liquids X and Y form an ideal solution. The mixture has a vapor pressure of 400 mm at 300 K when mixed in the molar ratio 1:1 and a vapor pressure of 350 mm when mixed in molar ratio of 1:2 at the same temperature. The vapor pressure of the two pure liquids respectively are. Now these type of questions are very easy. We have done these type of questions. You need to use the formula equation that sum of partial pressures will be total pressures. So total pressure will be equal to P naught X into its mole fraction plus P Y naught into its mole fraction. Form the two equations, solve it, get the answer. Solve it, because this is something we have done. Yes, Shashwat, that is very good. That's what I said. You remember that? Good. So form the equation and use the values. Don't even solve. In such questions, objective type questions, you can save time if you form the equations and do not solve those equations. Rather, use the values given in ABC and get the answer. Yes, Ashi, correct answer. Others also tell me the answer quickly. Shashwat, correct answer. Sudipta, Sohani, Yatika, Arohi, Ankur, Mehak, Tuhina. Tell me the answer. Yes, Yastika, correct. So I'll give you just a hint. In such questions, you just need to use P total. At P total, you know, in two forms you use. Okay. P2 naught minus P1 naught minus P2 naught x2, or just say P total equals to Px naught and xx naught plus Py naught. Say this one. Cap X capital Y to make difference, and Y Y naught. Here you don't need to put. Now it is 1:1 ratio. It means these two you can calculate easily, will be 0.5, 0.5. Substitute the values, get the answer. 1 by 2, 1 by 2. Okay. And in another case, P total will be Px naught. 1:2 means 1:2. Total 3. So 1 by 3, 2 by 3. Pure values are given, and you don't even need to solve it. That's what I am saying again and again. You don't need to solve, just use the values and get the answer. Okay. In this case, second case, it is 350. Right here 350, and just see which one satisfies the answer. Okay. So if you substitute the values, just these values, and see if that satisfies the answer or not. Okay. Otherwise, if you think that you need to solve it, then substitute here 1 by 2. In first case, it is 1:1. Okay, that's why I have written 1:1 will be 1 by 2 and 1 by 2 mole fraction. And this 250 is given 400. So if you want to solve, you can solve. Otherwise, you can substitute the values and get the answer quickly. Okay. So in this case, also D will be the correct answer. And you can get answer basically by this one, not by first one. Because if you just use the first one, this will also give you correct answer, A. Next question. A 6% solution of urea is isotonic with. We have done these type of questions. You just need to equate the concentrations. Isotonic means C1 RT equals to C2 RT cancelled. Means concentrations need to be same. Okay. 6% solution means 6 out of 100. Okay. To calculate the concentration of urea and then compare it with glucose, you will get the answer. I'm just looking for answers first and then I'll explain. Okay, Preeta, correct answer here of this one. Mehak, no. Concentration needs to be same. So in which case concentration will be same. So first calculate the concentration of 6% solution of urea. That's it. That's what you have to do. Ashi, correct. Calculate the concentration of 6% solution of urea. 6% solution means in 100 gram, you have 6 grams urea, and urea molar mass is, I think 60 or 60 to 60. Yes, 60. Okay. So say this one is glucose, this one is urea, say. Okay. And if this is urea, it will be number of moles divided by remember when we are saying isotonic, we can have either molality or close to molarity. Okay, close to molarity. We will consider that it is the solution has the density as 1 gram per ml. Vanna correct. Yes, Preeta correct. Okay. So in 100 grams, 6 grams urea. 100 gram will be equal to 100 ml, 6 gram urea. So volume is 0.1 liter. 100 milliliter will be 100 divided by 1000, 0.1 liter. And 6 grams will give you number of moles given mass divided by molar mass, that is 0.1. So it will be 0.1 divided by 0.1. So C glucose will be 1 md. If anything is not clear, let me know. Don't hesitate to ask. Otherwise, if you think that you will be able to do it later on, if it is not clear now, you will not be able to do. I'm telling you. Next question. The difference between the boiling point and freezing point of an aqueous solution containing sucrose, molecular weight 342, in 100 grams of water is 105 degrees Celsius. Difference, it is difference, okay, between boiling point and freezing point. If Kf and Kb are given, the weight of sucrose in solution is. Question is very easy. Let me see who is going to tell me the answer. She no. Just assume that you have dissolved some X or W mass of the solute and then get the answer. Yes, she now correct. Similar questions will be there in your examination. Similar questions. So try to solve all these questions. Don't think that you will be able to do later on. There will be test tomorrow on this chapter. Do practice now. Okay, this much time was more than sufficient. Okay, you know the formula of delta TF and delta TB. Delta TB is given as KB into 1000 into say W2 you have, right, M into W1. KB is given, okay, 0.51. W2 you have calculate and W1 is 100 gram of water. Delta TB is elevation in boiling point, means TB minus TB naught. TB is greater than, okay, than the normal one. Standard is TB naught. And this is for water 100 degrees Celsius. It means TB minus 100 equals 2.51, something like this. Okay. So you got TB in terms of W2. Okay. So TB will be this 100 you move to here. Okay. And similarly, TF, and this is different depression. So TF naught minus TF will be KF into 1000 into W2 divided by M2 M into W1. TF naught is 0. This one is 0. So get the value of TF. TF will be minus 1.86 into 1000 into W2 divided by 342 into 100. This is the value of TF you got. Get the value of TB minus TF. So TB minus TF, this is given 105. Okay, this one, difference between boiling point and freezing point, will be whatever you have calculated here minus this one. So obviously this will add. Okay. So when you calculate this one, just give me few seconds. Or if you have done calculation, PB, 0.51, it will be approximately 0.0148. Okay. Whatever value you get, substitute those values, and this is given as 105. Okay. So when you substitute it as 105, you will get value of W2. This is the only unknown. Anything not clear, let me know. Yes. Check if you are not clear about it. It is, I'm just doing calculation. Give me a few seconds. 0.51 into 10 divided by 352. Yes, 0.0149. So you got here 100.0491. This total value, because you have to add 100 here, minus this value will be minus, let me do calculation again, 1.86 into 10 divided by 342, 0.0543 minus 0.5438, and you have W here. Oh, it will be different. It will be 100 plus 0.0491 W2, because 100 is here, it does not contain W2. So this is TB minus 0.05438 W. So from here you will get the value of W2, and once you calculate, you will get the value as 72 grams. Just calculate it and see whether you are actually getting that value or not. This 100 will go to the right hand side. 105 minus 100 will be 5. So it will actually be 5 divided by sum of 0.0491 and 0.05438. Yes, so D will be the answer. Most of you have got the answer. It is clear, it means. The amount of solute molar mass 60 gram per mole that must be added to 180 gram of water so that vapor pressure of the water is lowered by 10% is. So again, just apply the formula P naught minus P divided by P naught equals to N2 by N1, and you will get the answer. Okay, N2 will be W2 by M2, N1 will be W1 by M1. So you will get the answer. Substitute the values and get the answer. So I'm not doing this one. Easy question. A solution containing 1.8 gram of a compound, empirical formula is given CH2O in 40 grams of water is observed to freeze at this much. It is in water. Water's freezing point 0. After adding 1.8 gram, it lowered. The molecular formula of the compound is, means you need to calculate molar mass And empirical formula mass you already know. You need to get the value of N, molecular formula mass divided by empirical formula mass. By this factor, you have to multiply the given empirical formula. To calculate the molar mass, how to calculate the molar mass? You know, delta TF equals to KF into 1000 into W2 divided by M into W1. So from here, you will calculate M2. You will divide that by empirical formula mass. Empirical formula is CH2O. So it will be 12 plus 2 plus 16, 30. So divide that by 30 and you will get the answer. So most probably, as far as I remember, you will get M2 as 180 and value of N will be 180 divided by 30, that is 6. So you need to multiply CH2O by 6 and D will be the answer. CH2O, when you multiply by 6, it will be C6H12O6. Yes, correct. Ashi, correct answer. Shashwat, correct answer. Next, 58.5 grams of NaCl and 180 gram of glucose were separately dissolved in 1000 milliliters of water. Identify the correct statement regarding the elevation of boiling point of the resulting solution. Read the statements and tell me the answer. There are two separate solutions, remember. In one case, NaCl is dissolved in water. In second case, glucose is dissolved in water. Okay, Mehak, think again. Think in terms of ionization also. Whether any of these will ionize. Ashi, correct. Arohi, correct. Those who are not responding, respond. Solve these questions right now. Okay, Shashwat, correct. Vanna, correct. Good. Now, if you see molality, molality will be same. MnACl is number of moles given mass by molar mass divided by sorry 1000 grams of water. 1000 ml means 1000 gram of water. Same. Similarly, M glucose 180 molar mass of glucose 180 divided by 1000. Same. 1 by 1000, 1 by 1000. There is no difference. Okay. Now it is in grams, so we have to convert it in kilograms. So yes, so it means it will be 1, it will be 1. But NaCl will get ionized. So molality we got, yes, it is same. But if it gets ionized, you need to again think in terms of this. Remember, in case of freezing, we have talked about that the freezing point is inversely proportional to value of I. Now see here, delta TB is actually elevation. So TB is always greater than TB naught. This is, you have to calculate. TB naught is constant. Okay. For example, for water, it is 100 degrees Celsius. Boiling point, standard boiling point, 100 degrees Celsius. So it is TB minus 100. For example, water is proportional to I. AB is same for water. M is same in this case. So when it will be higher, directly proportional. TB will be higher if I is higher. Okay. So TB is directly proportional to I. TF is inversely proportional to I. So here in NaCl case, I is 2 because NaCl gets ionized in Na plus and Cl minus. So I is after, before, that is 2. In case of glucose, it is 1 because glucose does not get ionized. So if glucose does not get ionized, 1. So in case of NaCl, value of I is greater, Tb will be greater. So higher elevation in case of NaCl. A will be correct answer. Next, freezing point of an aqueous solution is minus 0.186 degrees Celsius. If the values of Kb and Kf of the water are given, then the elevation of boiling point of the solution is. Now this one is very simple question. Just note down this question you need to do. I am just moving forward. Freezing point is given, solution. Okay. Elevation of boiling point you have to calculate. What is unknown? What is common in these two, freezing and boiling here? The equations, which is something, what is, tell me just what you have to calculate from the given information or cancel out from the given information. What is something which you will get from the given information and will use for boiling point? Which one is missing in the formula? Yes, Ashi, correct. Mm, no, Prita, that is something we know. My question is, Shashwat, that what you will use from the given information in the information asked. For example, freezing point related to freezing information is given and question is about boiling point. So what is missing which you will get from the data given and will use to calculate the boiling point? Yes, Preeta, correct. Sohani, no, that is given. That is given. Something is missing which you have to get. Okay, Mehak, correct. Now, just if you think there is any confusion, write the formula. Freezing point, if we are talking about, it is like this. And if we talk about boiling point, for boiling point, we need delta TB. What is given? This is given, minus 0.186. Kf is given. It means this is M which you will get from here and use it here. Okay. And for that, you don't even need to calculate M. Remember, in all such cases, don't ever calculate M. Write both the equations, first and second, and divide. When you divide, you will get delta TF divided by delta TB equals to KF divided by KB. Substitute the values, get delta TB. Once you get delta TB is actually TB minus TB naught. So whatever value you get from there, you can get TB because TB naught is 100 for water. Okay. So when you substitute the values, you get the answer. So delta TF will be 0 minus, sorry, it will be actually TF minus TF not TF not minus TF. This one will be delta TB will be TB minus TB naught equals to KF by KB. So I'm using this one, okay? This one. TF naught will be 0 minus 0.186 divided by TB we have to calculate. TB naught is 100 equals to KF is 1.86, KB is 0.5. The only unknown is TB. You will get the value as 0.052. No, elevation is asked. Okay. Elevation is asked, not the boiling point. So you just need to calculate delta TB. You don't need to change it. So that is even easier. Delta TB will be so low. TB cannot be 0.052. TB will be greater than 100. Next question. The mass of a non-volatile solute of molar mass 40 gram per mole that should be dissolved in 114 grams of octane to lower its vapor pressure by 20% is. Now this question is again very easy. Just you need to understand 20% means 20 gram in 100 grams and you will get the answer. So write P naught minus P divided by P, lowering in vapor pressure, will be equal to N2 by N1. Okay. N2 by N1. Now you need to calculate N2 and N1. So it is molar mass 40 dissolved in 114 gram of octane. Octane is 114 grams and depression is 20%. So you need to assume, you will have to assume the mass of non-volatile solute. So assuming the mass of solute is X. So if mass of solute is X, moles of solute will be given mass upon molar mass 40, which is given. And moles of solvent N1 will be that should be dissolved in 114 grams of octane, given mass divided by molar mass of octane. We have to calculate CH3, CH2, 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 CH3. 1, 2, 3, 4, 5. Means CH3 whole twice. Okay. 30 plus CH2. 14. 1, 2, 3, 4, 5, 6. Okay. 114. So it is 114 divided by 114 number of moles of octane. So N2 known in terms of X, N1 this one. So from here you will calculate N2 by N1. Okay. And this relative lowering is given 20% means 20 by 100. So it will be 20 by 100 equals to N2 divided by N1. Remember, I am writing in approximation, and 2 by N1 is in approximation case only. Solve it means it will be X by 40. So X equals to 20 into 40 divided by 100, that is 8 grams. So A will be the answer. Yes, Shashwat, Ashim, and Vanna, correct answers. Good. Next one, again, very easy question. The vapor pressure of two liquids A and B in their pure states are in the ratio of 1 is to 2. A binary solution of A and B contains A and B in mole proportion 1 is to 2. The mole fraction of A in vapor phase of the solution is. Just simple formula. If you could understand the question first. Just assume, because it is ratio given, if you assume is P, it will be P is to 2P, okay? P and 2P. So just as a hint, I am telling you, just assume vapor pressure of A as P. So vapor pressure of B will be 2P. And then apply the formula of total vapor pressure. Remember, in first sentence, ratio of vapor pressures is given. In second statement, ratio of their moles are given. Ratio of vapor pressure is also 1 is to 2. Ratio of moles is also 1 is to 2. You need to calculate the mole fraction of A in vapor phase. And you know the formula for vapor phase, mole fraction. Preeta, correct answer. Good. Ashi, correct answer. Armina, correct answer. Sohani, correct answer. This much time is sufficient for this one. So vapor pressure PA, if it is P, okay, PB is total vapor pressure basically if we apply, okay, P total. Just I am writing, I am skipping one step, okay. So if vapor pressure of A is P and vapor pressure of B is 2P, then total pressure will be P and its mole fraction. Mole fraction is 1 by 3 plus 2P into mole fraction of B. Mole fraction of B will be 2 by 3. 2 by total. Total 1 plus 2, 3. 1 by 3, 2 by 3. Means P by 3 plus 4P by 3 means 5P by 3. So P total we got 5P by 3. But in vapor phase, mole fraction, we know the formula that Py is equal to P total Then mole fraction in vapor phase, YA. You know that. Py, that is partial pressure in vapor phase, is equal to P total multiplied by mole fraction in vapor phase, not in solution. So applying this, you get Py, you already know. Okay. What is Py? In case of A, it is P by 3 partial fraction, which is equal to P total. And what is P total? P total you got 5 by 5 P by 3 into YA. So YA from here you got P by 3 divided by 5P by 3. That is P by 3 into 3 by 5P. That is 1 by 5. 1 by 5 means 0.2. B is the correct answer. If there is any confusion, you can let me know. Yastika, yes, Shashwat Swami, correct. Next question. The measured freezing point depression for a 0.1 m aqueous acetic acid solution is given. Measured freezing point, okay, depression. So this is delta TF. The acid dissociation constant Ka at this concentration will be, Kf is given. So you have been asked Ka. Tell me the answer. Molality is given 0.1, delta TF given, Kf given, and as a hint, acetic acid will dissociate as per the given reaction. Ahan, yes, correct answer. Just as a hint, from the given values of delta TF, M, and Kf, calculate the value of I. You know that delta TF is equal to I Kf M. Everything except I is known. So from here you will get value of I. And from this equation also, if it is 1, 0, 0 here, and after the situation 1 minus alpha, or say x, whatever, if you want to do alpha and alpha, that is after it will be 1 plus alpha, before it was 1. So I from here will be 1 plus alpha after divided by before, that is 1 plus alpha. And 1 plus alpha you will equate to this value, both I you will equate, and you will get the value of alpha. Once you get the value of alpha, acetic acid is very, very weak acid, and for that Ka is given by just C alpha square, not divided by 1 minus alpha. Otherwise, it is C alpha square divided by 1 minus alpha, because it is very, very weak acid. This alpha is very small. So 1 minus alpha can be just 1, C alpha square. So substitute that value of alpha here. C is anyway considered point 0.1. Point 0.1 m is given molality. Approximately, you will consider that as molarity. Ashish, Shashwat, Preeta, correct answers. So the value of I from here, you will get delta TF 0.19 divided by 1.86 into 0.1. So 0.19 divided by 0.186. So just can anyone confirm I am audible or not? Okay, good, fine. So there was some disconnection, so that's why I asked. Okay, thank you. So from here, it will be approximately 1.02. This is slightly less than 0.19. Yeah. So 1 plus alpha you will equate to I. So alpha from here you will get as 0.02. Substitute those values and you will get it as 4 into 10 to the power minus 5. So B will be the correct answer. So the unknown was I. So you calculated I. Then you got the value of alpha. You got the I from this equation also. The value of I from this equation. Equated both values of Van't Hoff factor. Got the value of alpha. Substituted that value of alpha here to get the constant. Dissociation constant. Next question. The vapor pressure of pure benzene and toluene at a particular temperature are 100 millimeter and 50 millimeter of Hg. Then the mole fraction of benzene in vapor phase in contact with equimolar solution of benzene and toluene is. First read the question and then I'll explain if you don't get it. Question is easy, just slightly tricky. Just to understand. Otherwise, it is easy. If you can understand, it is easy. If you can understand, this is 1 minute question. I hope I am audible to everyone. Okay, so try to understand what I am saying. The question says vapor pressure of pure benzene and toluene, pure, at a particular temperature are 100 millimeter and 50 millimeter. Means pure benzene, if benzene I am taking as 1 and toluene I am taking as 2. So in that case, P1 naught for benzene is 100 mm and P2 naught is 50 mm. That is given. Okay. Then it says then the mole fraction of benzene in vapor phase in contact with equimolar solution of benzene and toluene. So means you have equimolar solution of benzene and toluene. When moles are equal, mole fractions will be 0.5, 0.5. For equimolar solution, x1 will be equal to x2 and both will be equal to 0.5, 1 by 2, 1 by 2. So if you know this, you can get the answer very easily. Okay, means for benzene, P1 will be P1 naught x1. For toluene, P2 will be P2 naught x2 and x1, x2 are equal. P1 naught is 100 into 0.5, that is 50 mm. P2 naught, that is toluene, is 50 into 0.5, that is 25 mm. So you got P1 and P2. Total pressure will be sum of these two. P total will be partial pressure added 50 plus 25, 75 mm. And you have to calculate the mole fraction of benzene in vapor phase, and you know the formula now. When you know the P total will be equal to, sorry, Y benzene will be P total into P1, right? No, I have written opposite P1 here. Okay. So P1 will be P total into Y1, and we have been asked to calculate Y1. So Y1 will be P1 divided by P total, and P1 we have calculated as 50. P total we have calculated as 75. So 50 divided by 75 will be 0.61. 2 by 3. 2 by 3 means 0.61. It means A will be the correct answer. Yes, Preeta, Mehak, she correct. 0.67. Now the last question today. An aqueous solution containing 3 gram of solute of molar mass, this one, in a certain mass of water freezes at this. The mass of water in grams present. This is very easy question, the last one today. So just write the formula and you will get the answer. Delta TF is equal to KF into 1000 W2 by M2 into W1. W1 you have to calculate. Delta TF is depression in freezing point. Okay. So 0 minus 0.125 equals to KF 1.86 into 1000 into W2 is given 3 grams divided by M2 is given 111.6 grams per mole into W1. That's what you have to do. Get the answer. So this will become plus 0.125. So W1 will be equal to 186 into 1000, sorry, 1.86 into 1000 into 3 divided by 111.6 into 0.125. 0.125 is actually 1 divided by 8. Okay. 1 divided by 8. So if you remember these things, it will make your calculations easier. So 1.25, 0.125, actually you can write 1 divided by 8. It will make your calculations easier. So when you solve this one, you get answer as 400 grams.